Hi everyone, welcome to the Lakeview Traffic Study presentation. This presentation is prepared by David, Nivajan, and Junjun. The project site is located in Mississauga. The project is a redevelopment plan for the waterfront village that is going to be accommodating the growing population of Toronto. The project team is asked to do a traffic impact assessment to anticipate the future traffic volumes that will be created due to the development. The development of the project site is divided into four major sections. The Ogden Green, which is centrally located, acts as a collection of the Lakeview waterfront community. The Cultural Waterfront, which is the mixed-use focal point at a pedestrian scale, and also it serves as a major sightseeing spot that attracts visitors. The waterway area will become the marina, and the Innovation Corridor will become a center of the office and institutional land use. There are three main intersections that we look into during the project. From west to east, they are Lakeshore Boulevard and Ogden Avenue, Lakeshore Boulevard and Hydro Road, as well as Lakeshore Boulevard and Dixie Road. Now, before we jump into the analytical part, I would like to discuss a bit about the data that we acquired. We obtained our traffic volumes from master plan, and our signal timing was obtained using the optimal signal timing calculation methods we learned in class.
In order to compensate for the discrepancy of volumes between each intersection, a ghost link was created. So for example, for the AM peak hour, we have 1,061 vehicles going eastbound on Ogden Avenue and Lakeshore Boulevard. However, we have 1,052 vehicles incoming from the west at the intersection Hydro Road and Lakeshore Boulevard. Therefore, we have a discrepancy of 9 vehicles between each intersection. The link was used to remove 9 vehicles and balance out the volumes.
Okay, so now we're going to be talking about the current conditions that we simulated through Vision. Some of the major things that we witnessed was that there are only 2 lanes available for each direction along eastbound and westbound of Lakeshore Boulevard. There were no bike lanes provided in any of the areas that we analyzed. And we did witness that there are a low amount of traffic volumes entering or exiting from Hydro Road. This is probably because the surrounding area has not been developed in a way that there's a lot of buildings and infrastructures around the area, so not a lot of traffic will be entering or exiting that area. So here's a video of the vision simulation that we conducted of the existing conditions. So here is Lakeshore Boulevard, Ogden Avenue. There's only a decent amount of traffic going eastbound and westbound. Here you can see Lakeshore Boulevard and Hydro Road. And then here you can see Lakeshore Boulevard and Dixie Road. Here you can see that there's a bunch of traffic going east and westbound and these are coming from the southbound direction.
In order to ensure that the model created can properly represent the current traffic conditions of the network, a model calibration must be done. In order to calibrate the model, the team has used a commonly used statistical measure within the transportation industry, called the GEH statistic. The GEH statistic is used in traffic engineering in order to compare 2 sets of data and assess the variance between them. The formula for GEH statistic can be seen on the slide above, where M represents the hourly traffic volume from the model and C represents the real-world hourly count. In order to ensure that the current conditions modeled are accurate, the GEH statistic for the volumes must have a value of less than 10. A value between 0 and 5 is considered a good match, while a value between 5 and 10 should be further investigated to assess the possibility of errors in the model. In order to ensure that all components of the model meet a high degree of accuracy, the team has decided to examine the GEH statistic for each movement of the intersection for both AM and PM peak hour periods. A summary of the GEH statistic can be seen on the following slides. For Lakeshore Boulevard and Ogden Avenue, the movement with the highest GEH statistic is the southbound left movement with a GEH of 3.2 for the AM and the northbound left movement with a GEH of 1.41 for the PM period. For Lakeshore Boulevard and Hydro Road, the movement with the highest GEH is the eastbound through movement with a GEH of 1.85 for the AM period and the eastbound left movement with a GEH of 1.47 for the PM period. For Lakeshore Boulevard and Dixie Road, the movement with the highest GEH statistic is the northbound right movement with a GEH of 1.41 for both AM and PM periods. Therefore, since no movement has a GEH greater than 5, we will proceed to the next step of our simulation since the model is well calibrated.
Okay, so before we began our business simulation for our future conditions and the different scenarios, we had to account for the traffic that would be projected. So we took the future conditions of 2041 to have a better, more accurate simulation on Vism to determine what kind of traffic we'll be dealing with. So we took the traffic volumes from the transportation report for all three intersections, and we saw that a lot of traffic will be going northbound towards Lakeshore Boulevard from Street G and Hydro Road, since those will be becoming a major road after the development is completed. So the first simulation scenario was that we want to start off by retiming our traffic signals at all intersections. So we did this to get a feel of maybe this would be enough to solve all the problems with the view conditions. And this is what resulted from our simulation. So as you can see that Lakeshore Boulevard and Ogden Avenue had a major congestion of traffic, and the same problem occurred along Lakeshore Boulevard and Hydro Road because of the overwhelming traffic coming from the northbound direction. And Lakeshore Boulevard and Dixie Road had an overwhelming amount going leftbound, and they're all stuck there because of the traffic signals that we coordinated. Okay, for our second scenario that we simulated, we want to take more of a drastic measures based on what we saw in our previous simulation with all the congestion at all three locations of our analysis. So what we did was we retimed our traffic signals at all the intersections again. We signalized the intersection for Hydro Road to accommodate for the overwhelming traffic that's heading northbound towards Lakeshore Boulevard. We increased the number of lanes along Ogden Avenue, Hydro Road, and Lakeshore Boulevard going east and westbound. We changed the left turn signalization at Lakeshore Boulevard and Dixie Road. So at Dixie Road heading northbound, we changed this into a left turn underpass. This is because we saw an overwhelming amount of traffic headed northbound from Lakeshore Road. So instead of having to wait for the traffic signals and cause a more congestion in that area, we just allowed them to take an underpass and merge on to Dixie Road heading northbound to reduce the amount of traffic. And in addition, we added okay, so here you can see Lakeshore Boulevard and Ogden Avenue. You see the traffic's flowing much nicer now with 3 lanes going east and westbound and 2 lanes going north and southbound. And here you can see Lakeshore Boulevard and Hydro Road. So in this, we added 2 lanes going north and southbound along Hydro Road to accommodate for the amount of traffic. So here's Dixie Road. As you can see, is a better intersection now after we cleared all the traffic congestion issues due to the leftbound direction. And now we're going to show you a POV simulation of a car going. Okay, so here is Lakeshore Boulevard and Dixie Road. As you can see, it's a much better intersection now after the major changes that were made for this particular intersection. So now you're going to be seeing a POV video of Lakeshore Boulevard and Dixie Road's left turn underpass and a vehicle making this turning movement. So as we get closer to the intersection, the vehicle is going to turn left and go through the underpass and merge onto Dixie Road going northbound through and merge.
For the AM period, Scenario 1 had a performance of LOSD for Ogden Avenue and Lakeshore Boulevard and a performance of LOSF for Lakeshore Boulevard and Hydro Road and Lakeshore Boulevard and Dixie Road. Scenario 2, which contains improvements such as lane additions, performed better than Scenario 1. Scenario 2 had a performance of LOSB for Ogden Avenue and Lakeshore Boulevard and an LOSC for Lakeshore Boulevard and Hydro Road and Lakeshore Boulevard and Dixie Road. We have also taken a look at the critical movements for each intersection. For Scenario 2, the critical movement for all intersections is LOSD, meaning that the worst performance seen in that intersection is LOSD. Since the LOSD is acceptable for peak hour conditions, Scenario 2 is a viable solution while Scenario 1 isn't. For the PM peak conditions, the network performed in a similar manner than in AM conditions. It is important to note that LOS values for Scenario 1 are below LOSD, therefore this scenario is not acceptable. With implementation of lane additions, signal optimization, and the addition of an underpass in Dixie Road, the performance of the network was able to be kept at or above LOSD. Therefore, scenario 2 is our recommendation in order to be able to accommodate for the traffic volumes of 2041. Thank you for watching.